when it blows, it could destroy the United States as we know it.
Yellowstone National Park is a land of awe-inspiring beauty that hides a potentially catastrophic secret. With nature's fury boiling just beneath the surface, scientists have been left reeling by ominous signs of change. A swelling dome-shaped uplift, tumultuous water levels in Yellowstone Lake, and a giant crack tearing through the Earth's crust, each hinting at a terrifying truth. The Yellowstone supervolcano may be stirring from its slumber. Are we about to experience a geological nightmare? Join us as we explore Michio Kaku's urgent warnings and examine the chilling possibility of a geological event of unprecedented magnitude. Yellowstone supervolcano, a colossal entity, lies dormant in the western region of the United States. Despite sporadic movements, it has remained in a state of slumber for almost 70,000 years. Its magnitude continues to grow, hinting at an imminent and extraordinary event that may unleash an unprecedented force. Is this going to be catastrophic? Why exactly is Michio Kaku weighing in on this matter? Let's break it down. Examinations of the volcano's ancient history do offer some insight. Geological evidence indicates that Yellowstone has experienced 3 massive eruptions in the past 2.1 million years. Volcanologists estimate that these eruptions occurred approximately every 600,000 to 800,000 years. The most recent significant event, believed to have taken place around 640,000 years ago, left its mark across the park and extended thousands of kilometers into the surrounding landscape. Each of these previous eruptions released vast quantities of volcanic ash, gas, magma, and other debris, which blanketed a significant portion of the continental U.S. Some remnants have even been discovered as far as Louisiana. Following each eruption, the Yellowstone supervolcano collapsed inward, engulfing trees, mountains, and everything else in its path. The resulting depression is known as a caldera. In fact, the Yellowstone supervolcano is often referred to as the Yellowstone Caldera. A caldera-forming eruption would pose a significant natural hazard in Yellowstone. The notorious eruption of Mount St. Helens in 1980, which resulted in the loss of numerous lives and extensive damage to the surrounding areas in Washington and Oregon, is nothing compared to the immense power unleashed by the Yellowstone supervolcano during its last eruption. Scientists estimate that this cataclysmic event, which occurred thousands of years ago, was 1,000 times more devastating than the eruption of Mount St. Helens. During the Yellowstone eruption, a colossal plume of scorching ash, molten rock, and deadly gases shot thousands of meters into the atmosphere. The sheer magnitude of this eruption caused a third of the continent to be enveloped in complete darkness. The region experienced the terrifying onslaught of pyroclastic flows, which raced through the landscape at alarming speeds, obliterating everything in their path with a combination of searing hot rock fragments and suffocating gases. The once picturesque landscape was transformed into a charred expanse as magma erupted from the ground, leaving a trail of destruction spanning kilometers. Is this why Michio Kaku is alerting us so that we can avoid history repeating itself? Meanwhile, evidence of this monumental eruption can still be observed within the Yellowstone Caldera, a massive crater measuring 50 kilometers wide and 70 kilometers long. The remnants of the volcanic debris known as the Lava Creek Tuff serve as a reminder of the sheer power and devastation unleashed by the Yellowstone supervolcano during its last eruption. The Yellowstone supervolcano, a massive geological formation, is situated beneath Yellowstone National Park, a vast area spanning across Wyoming, Idaho, and Montana. Specifically, the volcano is located in northwestern Wyoming, which encompasses the majority of the park. Beneath the surface of Yellowstone, there exists a hotspot composed of molten and semi-molten rock known as magma. This magma flows into a reservoir called a magma chamber, which lies approximately 10 kilometers, 6 miles, beneath the park. As the magma fills the chamber, the ground above it swells. However, when the magma cools and solidifies, the ground subsides. Volcanologists have been monitoring the volcanic activity since 1923 and have observed that the ground rose approximately 25 centimeters, 9.8 inches, between 2004 and 2009. However, in 2010, the land started to sink. However, the prolonged period of gradual and consistent elevation has raised concerns among scientists regarding the possibility of an imminent eruption at Yellowstone. Moreover, there is apprehension about the potential intensity of such an eruption. The recent underground activity has further fueled speculation about the magnitude of the eruption. Over the past decade, the volcano has experienced the highest rate of ascent ever documented. Yellowstone typically experiences around 1,000 to 3,000 earthquakes annually. The majority of these tremors go unnoticed, measuring at a magnitude of 3 or lower. Nevertheless, these seismic activities provide valuable information to scientists regarding the rate at which the magma chamber beneath the park is being replenished. A surge in seismic activity across the park could suggest that a new supply of magma has been introduced into the reservoir. Despite the rise in earthquakes, experts believe that the seismic activity in the magma chamber does not present an immediate danger. Nevertheless, due to the lack of comprehensive monitoring of all events in Yellowstone, it remains challenging for geologists to forecast the park's future behavior accurately. Does this mean nobody knows when a geological eruption is about to happen? Let's take a look at Yellowstone Caldera. Yellowstone Caldera. Following the recent super eruption, the magma chamber beneath the caldera has been gradually refilling, resulting in a fascinating geological occurrence: the emergence of resurgent domes. This natural process has caused the caldera floor to rise, forming two expansive uplifts in the shape of domes: the Sour Creek Dome and the Mallard Lake Dome. To better comprehend the concept of resurgent domes, envision a colossal subterranean balloon being filled with magma or molten rock. As this balloon expands, it exerts pressure on the ground above it, just like a bubble forming in dough while it is being baked. Consequently, the ground swells and takes on a dome-like shape, hence the term resurgent dome. These domes are not mere insignificant protrusions on the landscape. They are immense in size, spanning over 10 kilometers in width and rising hundreds of meters above the caldera floor. The Sour Creek and Mallard Lake domes, while sharing a common origin, exhibit distinct differences in their development and composition. The Sour Creek Dome, for example, emerged above the neighboring caldera rim and continued to grow until it reached its maximum height, resembling a massive mound. Its surface is characterized by numerous faults, akin to fractures formed as the dome pushes against the surrounding rock, in response to the intense uplifting forces. Conversely, the Mallard Lake Dome not only experienced an early uplift, but also underwent a significant resurgence approximately 170,000 years ago. During this later phase, the eruption of the Mallard Lake rhyolite flow deposited a new layer of rock across most of the dome's surface, expanding its overall volume. These distinct geological events highlight the intricate nature of these domes, showcasing their complex history beyond mere hills. That's not all. These resurgent domes play a vital role in understanding the current geothermal activity in the park and potentially predicting future volcanic events. The uplift and deformation of the caldera floor, as demonstrated by these domes, suggests the ongoing activity of the Yellowstone volcanic system. Despite its tranquil appearance, the park conceals a restless giant beneath, reshaping the very ground we tread upon. The initial recognition of the dome's significance serves as a mere introduction to a seismic wave of discovery, offering a glimpse into the vast mysteries and geological marvels waiting to be uncovered in this dynamic and ever-evolving landscape. Michio Kaku's profound exploration of the Yellowstone supervolcano brings to light a disconcerting reality. The eruption may already be underway. The sheer magnitude of this natural force in motion is undeniably unsettling. With his direct and insightful approach, Michio elucidates the genuine danger posed by supervolcanoes, particularly Yellowstone. He unravels the complex geological phenomena, instilling a sense of urgency and concern. This serves as a powerful reminder of the immense power lurking beneath our feet, capable of not only reshaping local landscapes, but also triggering global consequences. Michio fearlessly expresses his concerns, issuing warnings about the eruption of the Yellowstone supervolcano. His words serve as a wake-up call to comprehend and respect the forces of nature, which, though often silent, possess the potential to unleash unimaginable devastation. Michio Kaku's grave warnings align closely with recent scientific discoveries that have shed light on the mysteries of the Yellowstone Caldera. The discovery, brought to light through the meticulous observations of Dr. Robert Christensen and Robert Smith from the University of Utah, was uncovered due to a notable shift in water levels at Yellowstone Lake, as depicted in the USGS documentary. Bob Smith, with a profound interest in the subtle yet impactful changes taking place in the Yellowstone Caldera, noted that the water levels across various sections of Yellowstone Lake were not uniform. Rather, they fluctuated, indicating that the entire lake basin was tilting akin to a seesaw. While this occurrence may go unnoticed by a casual observer walking by the lake, to a geologist, it serves as a clear indication that the ground beneath is not as steady as it may seem. The tilting that occurred was not a minor event. It served as an indication of a significant geological shift beneath the calm waters. Picture yourself holding a shallow pan filled with water. If you tilt the pan slightly, the water level changes, with one side becoming higher and the other lower. This is precisely what was happening in Yellowstone Lake, suggesting that something profound and forceful was exerting pressure from below, disturbing the ground and consequently affecting the water above. This disturbance manifested as a dome-shaped uplift, a remarkable elevation of the land that Dr. Christensen described as breathtaking. This uplift could have been caused by magma, the molten rock beneath the Earth's surface, pushing its way up into the crust. Alternatively, it could have been the result of Yellowstone's hydrothermal system, a network of hot water and steam expanding and pushing the ground upward. Both scenarios indicate an active and evolving magmatic system beneath Yellowstone, a system that is not dormant but rather stirring, reshaping the landscape in ways that can suddenly become apparent. Before we continue with scientific discoveries during their research, let's look at supervolcanoes and the impact they left on the planet. The Toba and the La Garita caldera. The Toba eruption, also known as the Toba supereruption or the youngest Toba eruption, occurred approximately 74,000 years ago during the late Pleistocene era at the location of present-day Lake Toba in Sumatra, Indonesia. This volcanic event is considered one of the largest explosive eruptions in the history of our planet. According to the Toba catastrophe theory, this eruption led to a severe global volcanic winter lasting for 6 to 10 years, which in turn contributed to a cooling episode lasting for about 1,000 years. These climatic changes resulted in a genetic bottleneck in the human population. In 1972, an analysis of human hemoglobins revealed a limited number of variants. To explain the low frequency of variation, it was suggested that the human population had been extremely small, possibly only a few thousand individuals, until very recently. Further genetic studies supported the notion of an effective population size of around 10,000 for a significant portion of human history. Subsequent research focusing on the disparities in human mitochondrial DNA sequences indicated a rapid population growth from an initial effective population size of 1,000 to 10,000, occurring sometime between 35,000 and 65,000 years ago. Then the next is the La Garita caldera, located in the San Juan volcanic field in the San Juan Mountains near Creede, Colorado, is a massive caldera, an extinct supervolcano. It is situated to the west of La Garita, Colorado. The eruption that led to the formation of La Garita caldera is considered one of the largest volcanic events in Earth's history and is recognized as one of the most powerful supervolcanic occurrences. The aftermath of the La Garita eruption is believed to have affected a significant area of present-day Colorado, with the deposit known as the Fish Canyon Tuff covering a minimum of 11,000 square miles, 28,000 square kilometers, and having an average thickness of 330 feet, 100 m. This eruption resulted in a widespread ashfall. Once the ash from the supervolcano had cooled and compacted, the central part of the volcano collapsed, resulting in the formation of a vast caldera in the earth. This caldera, known as La Garita Caldera, spans an impressive 50 miles. Over time, the immense crater gradually filled up with ancient lakes, hot springs, and volcanic debris. Geologists propose that the activity of younger and smaller volcanoes eventually buried a significant portion of La Garita Caldera, particularly its southern rim. It is speculated that this section now lies thousands of feet beneath the surface, possibly concealed beneath layers of hardened ash from a more recent eruption that gave rise to the Creed caldera. So let's go back to what scientists discovered during their research. Monitoring ground formation. The monitoring of ground deformation at Yellowstone has seen a remarkable transformation throughout the years, now incorporating cutting-edge technology and modern techniques. Today, scientists rely on tools like GPS and INSAR to detect even the most subtle movements. These methods mark a significant advancement from the past, utilizing signals from satellites orbiting the Earth to precisely monitor ground shifts, swells, and sinks. In the past, geodesy, a branch of Earth science focused on understanding Earth's shape and variations, was the main approach for studying deformation. Geodesists used a meticulous method called leveling to measure vertical deformation, capturing both the rise and fall of the ground. This process involved using a surveying instrument called a level and a pair of graduated staff to carefully measure elevation differences between benchmarks. By consistently repeating these measurements across a network of points in the park, scientists could create a detailed map of ground movements over time. Subsequent surveys would then reveal any changes in these elevations over time. The first leveling survey at Yellowstone, carried out in 1923, has left a lasting legacy with some original benchmarks still in place today. Following the 1975 magnitude 6.1 earthquake, a survey carried out at Yellowstone National Park unveiled an intriguing finding. The central area of the caldera had undergone a notable uplift of over 28 inches since 1923, demonstrating an average yearly rate of 1.4 centimeters. This impressive uplift exceeded the impact of the earthquake alone, suggesting a considerable expansion of the ground. That's not all. While meticulously charting the variations in Yellowstone's ground level between 1923 and 1977, scientists made an astounding discovery. The largest ground rise was between two notable locations, the Mard Lake and Sour Creek Resurgent Domes, which are close to well-known sites like Old Faithful and La Hardy's Rapids. To understand this phenomenon, picture the surface of a trampoline that becomes saggy when weight is applied, but gradually regains its original shape when the weight is released. This comparison is similar to Yellowstone's slow elevation rise. Scientists continued to observe the ground's continuous uplift every year until 1985, starting in 1983. However, the landscape changed in 1985 as a result of a seismic swarm close to the caldera's northwest edge. Then, a process known as subsidence started to cause the gradually rising ground to sink back down. In an attempt to determine what caused this change, scientists theorized that steam, hot water, and magma that had accumulated beneath the surface may have begun to seep out of the caldera. This fluid release reduced the pressure that was causing the ground to rise. Beginning in 1995, the caldera floor's behavior became more complicated. The floor started to rise in some places while it kept falling in others, bringing about a change in the geological landscape. A new area of uplift surfaced, rising at rates never before seen in the area's historical records. In the midst of this seismic upheaval, scientists noticed a concerning correlation between these wild shifts in the Earth's crust and the waves of earthquakes that shook the region. However, it became evident that these vibrations and movements were not isolated incidents, but rather linked segments of a more extensive and frightening pattern. The surface of the caldera fluctuated, reflecting the deep, invisible processes at work below, such as the tectonic plate shifting and the unrelenting migration of magma. These natural occurrences alluded to the tremendous power that resides deep within Yellowstone. More terrifying information has recently surfaced. In the expansive wilderness of Yellowstone Park, on a typical day, guides in Grand Teton National Park made an astonishing discovery near the Hidden Falls. Overnight, A colossal crack emerged, standing at a towering height of 100 feet and stretching over a length of 300 feet, piercing through a rock wall in the Teton region. The abrupt and remarkable formation of this crevice gave rise to inquiries and apprehensions. What could have triggered such a momentous geological occurrence in an area that is frequently visited and closely monitored? Furthermore, what implications did its sudden appearance hold for a location in such proximity to the dormant behemoth, the Yellowstone supervolcano? The discovery of the Hidden Falls Fissure caused a stir in the scientific community and the public, highlighting the power of nature. Although the Teton area is not directly above Yellowstone's magma chambers, it is connected to the larger Yellowstone system, known for its seismic activity. The appearance of the fissure was not entirely surprising in such a volatile landscape. However, its proximity to the massive Yellowstone volcano has raised concerns to a new level. The Hidden Falls Fissure is a stark reminder of the ongoing geological processes beneath us. It is a result of the constant tectonic activity in the region where the Earth's crust is under immense stress, leading to fractures like the one at Hidden Falls. This event highlights the dynamic nature of the Earth's crust, especially in a geologically active region like Yellowstone, and emphasizes the unpredictability of nature. The imminent danger posed by the potential eruption of the Yellowstone supervolcano is a significant and alarming issue given the geological conditions in the vicinity. Although the last eruption of the supervolcano occurred roughly 630,000 years ago, the key question is, when will it erupt again? The catastrophic nature of Yellowstone. The vast magma chamber beneath Yellowstone consists of rhyolite and extends to considerable depths beneath the surface, providing evidence of the tremendous power and magnitude of the volcanic forces in action. The potential outcomes of a volcanic eruption at Yellowstone are nothing less than catastrophic. Although there is no need to cause alarm, comprehending the seriousness of such an occurrence is crucial, as it could have extensive effects not only in the nearby area, but also potentially on a worldwide level. Yellowstone National Park is situated on top of an immense supervolcano, considered one of the largest and most perilous in the world. Experts predict that upon its next eruption, the volcano will release a catastrophic force unlike anything witnessed in recent history. The eruption of the Yellowstone supervolcano would lead to the expulsion of massive quantities of ash into the atmosphere. This volcanic ash, more closely resembling fine sand rather than soft fireplace ashes, would cover the terrain, enveloping everything in its wake with a dense layer. The immediate aftermath of the ashfall would present significant challenges, with roads, railways, and airports being closed, rendering transportation nearly impossible. Individuals in the impacted regions would be required to seek shelter indoors to avoid inhaling the abrasive ash, which can result in respiratory issues and damage to machinery. That is just the beginning. The repercussions of ashfall extend beyond mere inconvenience. It has the potential to result in the collapse of roofs due to the excessive weight of the accumulated ash, which in turn disrupts power supplies and causes structural harm to buildings. Moreover, it has the ability to contaminate water sources, rendering them unsafe for consumption and exacerbating the difficulties faced by affected communities. Although the ash clouds may be the most prominent manifestation of a Yellowstone eruption, the gases emitted during such an occurrence could be equally, if not more, perilous. Sulfur dioxide is one of the main gases released, and when it combines with water vapor in the atmosphere, it creates sulfuric acid aerosols. These aerosols can then fall to the earth as acid rain, which can have severe consequences for the environment. Acid rain can acidify water bodies, harm aquatic ecosystems, and impact the quality of drinking water. Additionally, it can cause damage to vegetation, infrastructure, and buildings, while also posing significant health risks to both humans and wildlife. On the other hand, if Yellowstone were to erupt, one of the most immediate and concerning outcomes would be the occurrence of a volcanic winter. The eruption would expel large quantities of ash and gases into the atmosphere, resulting in the formation of a dense cloud. This cloud could obstruct sunlight for several months or even years. Consequently, this sudden and prolonged reduction in sunlight would cause a significant decrease in global temperatures. The aftermath of a volcanic winter would be catastrophic. A significant drop in global temperatures would result in crop failures, food scarcity, and widespread famine. Our modern society, heavily dependent on agriculture and global food distribution networks, would be severely tested. Human populations would encounter difficulties not just in obtaining food, but also in keeping warm and meeting essential living needs. Is there any measure to keep one safe from this catastrophic event? Or we just wait and let the sleeping giant wake up? The unpredictability of a Yellowstone eruption remains one of its most enigmatic aspects. Despite being one of the most closely monitored volcanoes worldwide, the United States Geological Survey diligently observes any unusual activity, such as tremors and ground movements, which they simply attribute to Yellowstone being Yellowstone. Nevertheless, the intricate geological forces at play make it challenging to detect the subtle and elusive signs of an impending eruption. Recent studies have indicated that the lead-up to a Yellowstone eruption may be briefer than previously believed. This raises concerns about our capacity to respond effectively in the face of an imminent catastrophe. The time available for evacuations, resource allocation, and disaster preparedness would be significantly reduced, intensifying the intrigue and urgency surrounding the situation. Is it possible that we may only realize the volcano is on the verge of eruption when it is already too late? Let's delve into history to gain a deeper understanding of the potential consequences of a supervolcanic eruption. The Yellowstone region has been shaped by previous eruptions and lava flows over thousands of years, offering valuable insights into the geological forces at work. Between 170,000 and 70,000 years ago, there was a period of intense volcanic activity in Yellowstone, characterized by a series of powerful and explosive eruptions that released vast amounts of lava across the landscape. Under Yellowstone lies a massive magma chamber containing molten rock, gases, and minerals. As pressure built up in the chamber, it sought out weak points in the Earth's crust, resulting in the eruptions we observe today. These historical eruptions were not only significant in scale, but also in the diverse range of volcanic phenomena they generated. The flowing lava filled the caldera, forming layers of solidified rock over time. The presence of colossal ash clouds and pyroclastic materials often accompanied these flows, resulting in a significant transformation of the region's topography. The impact of these volcanic eruptions on the landscape was profound, as the once rugged terrain was smoothed out by the dense and sticky rhyolite lava, creating a more uniform and expansive surface. Over time, natural processes such as erosion played a role in shaping this new terrain, giving rise to valleys, canyons, and other geological features that are observable in Yellowstone today. It doesn't end there. The heat emitted by the cooling lava played a crucial role in the development of Yellowstone's extensive hydrothermal system. This system fuels the mesmerizing geysers, hot springs, and fumaroles that contribute to making Yellowstone a geothermal wonderland. Additionally, the journey of magma, the molten rock beneath the Earth's crust, plays a vital role in the intricate relationship between volcanic activity and dome uplift. Following the massive eruption that formed the Yellowstone Caldera, the vast chamber that had been emptied of its magma initiated a gradual and relentless process of getting filled again. However, the source of this magma and the mechanism behind the creation of resurgent domes, such as the recently uncovered one, remain a subject of inquiry. Magma is believed to have its origins in the mantle, a region beneath the Earth's crust, characterized by elevated temperatures and pressures that facilitate the melting of rock. In regions like Yellowstone, a combination of heat emanating from the Earth's core and various geological processes give rise to localized pockets of molten rock. Gradually, this magma ascends through the crust, navigating its way through fractures and areas of structural vulnerability, driven by both buoyancy and the immense pressures exerted from the depths of the Earth. Beneath the caldera, magma gathers and applies an upward force on the rock above it. Picture the surface as a lid on a pot of boiling water. Just as steam pushes against the lid, magma pushes against the Earth's crust. In Yellowstone, this pressure does not result in an immediate explosion. but rather a slow rise. The ground swells as if inhaling deeply. Sour Creek and Marred Lake domes, likely weakened areas from past volcanic events, serve as focal points for this upward force. The intrusion of magma causes the ground to bulge upwards, forming the domes. The reason why magma does not always cause an eruption lies in its characteristics and the surrounding rock. Not all magma is the same. Its composition can significantly impact its behavior. In Yellowstone, the magma is often rhyolitic, a viscous type that flows slowly and can trap gases. This can lead to explosive eruptions when pressure builds up. However, if the magma can gradually release this pressure, such as by lifting the ground above it, an eruption may not occur. The role of the rock above the magma chamber in volcanic activity is crucial. If the rock is both strong and flexible, it has the potential to form a dome instead of breaking, which prevents an eruption from occurring. One thing we hope for is that this sleeping giant remains asleep. If you like this video, please give us a thumbs up, drop a comment in the comment section, and turn on your notification bell.